Nicole again, friends. In this video we are going to be talking about the alternating series test. So before we begin using our alternating series test, the first thing we have to do is we have to determine whether or not our series is actually an alternating series. Now the only thing we have to identify in order to do this is we have to be able to tell, and when looking at our series, if we see this -1 to the n or -1 to the n minus 1. This is what makes a series an alternating series, because what it does is it takes our pieces, our terms within our series, and for every term it switches the sign. So for this guy right here, when we plug in our n, first n, we have 1, 1 minus 1 is 0, anything to the 0 is just 1, right? So you have a positive 1. Then we plug in 2. 2 minus 1, we're going to get 1. -1 to the 1 is going to get us a negative. Plug in 1 again, or 3, excuse me. N equals 3, you get 3 minus 1, you're going to get 2. Anything squared is positive. So you see that into infinity, the signs flip for each term in our series. The same thing can be said for this guy. The only thing is we're going to start off with a negative and go to a positive. Negative, positive. Our terms are going to switch right from the get-go. So what we're going to be looking for, like I said, to determine alternating series is this -1 to some n power. Once we've identified that as an alternating series, we can then go ahead and we can use our alternating series test. So our alternating series test states that if we have our Bn, which is this stuff multiplied after our n minus 1, if our Bn is positive and decreasing, and the limit of Bn as n goes to infinity is equal to 0, then you conclude that your alternating series is in fact convergent. So let's use this example we have here to kind of test this and demonstrate how this all works out. So we know it's an alternating series test, right? Because we have our -1 to the n. So that's one thing we know. So now we have to use our knowledge of our Bn to figure out what happens next. So we know that first thing we have to conclude is whether or not our Bn is positive, right? So let's look at the pieces in our Bn. We have e to the 1 minus n. We know that the graph for any function e to some power, right, is going to look something like this, right? There's nothing down here in the negative part of our graph. So we can conclude that the range is just positive numbers. Anything that this spits out then is going to be a positive number. Similarly, in our denominator, our n goes from from 1 to infinity. So these are all positive numbers. Our n can only be a positive number. So a positive over a positive will always be a positive. So we've concluded that our work will get us positive. So we have positive. So now we have to conclude, will we get decreasing? So a really quick, easy way to determine this is let's just graph him. So graphed him on my calculator, and we can clearly see that the curve is just clearly nice and easy going down into infinity. So we have positive. Now we know that he's decreasing. We have to now determine the limit. So we have to look at the limit of our Bn as n goes to infinity. So that's e to the 1 over n all over, well, this is kind of hard to see. Sorry, friends, hold on, let me switch. Here we go. We're going to do the limit. Wait, this is my dead marker. So sorry. 1 second, friends. Here we go. Okay. We have the limit as n goes to infinity of e to the 1 over n all over n. So if you plug in our infinities, right, we're going to get e to the 1 over infinity all over infinity. We know that 1 over infinity is the same thing as saying e to the 0 all over infinity, which is the same thing as saying 1 over infinity, which we know is 0. So our limit then we know is equal to 0. So all three of these conditions check out. We therefore know that our series is convergent.